Hello, ladies and gentlemen of Algebra 2. This is Mr. Heron talking to you about 2-4, talking about special functions. Now, these are kind of unique situations. So they're not linear, they're not quadratic, they're a little bit different than things you might have seen before. So one of the big ticket items here is that you need to be able to determine what's a linear step, absolute value, constant, identity function by looking at the data, the graph, or the function and be able to tell what kind of graph or what kind of function that's going to be. So if I take a look here, all right, weight not over ounces. So if it's up to 1 ounce, it's going to be 39 cents. If it's up to 2 ounces, it's going to be 63. Up to 3 ounces, 87, and so on and so forth. So is this linear function? Well, without thinking about it, you're probably going to say yeah, or pretty close, because if you're going to take just go by common differences, yeah, that's 24, that's 24, that's 24. So it's a constant difference, you might think yes. But look what it says, weight not over 1 ounce. Okay, weight not over. So that means that if you've got a 1.2 ounce letter, you're going to be charged for 2 ounces. Okay, if you got a 0.5 ounce letter, you're going to be charged for a 1 ounce. All right, same if you have 0.7, you're going to be charged for 1 ounce. Okay, so it's not really a linear function, because for any value up to that, you're going to get up to that next ounce. So for 1.5 ounce, you're going to get charged like it's a 2 ounce letter, and you're going to have to pay 63 cents on it. So that's why it's not going to be a linear function. So the answer to that question, no, okay, because all those values go up to the next ounce. So a step function is actually what it is. So kind of what this means is that for any given range of values, all right, and here's kind of the function in mathematical form. So that means that for any range, you're going to give one value. So this is what it looks like as a graph. So kind of how does this relate? Well, let's look at this one. So 3 is less than or equal to x is less than or equal to 4, and that means that the value is going to be 3. So if I go between 3 and 4, so 1, 2, 3, 4. So between here and here, all right, it's going to be up at 3. All right, so 3 is that value there. But now notice how it's written, okay? 3 is less than or equal to x. That means that I'm going to have a solid dot first, because once I hit 3, I'm at 3. So that's what that's going to look like. So a couple things to remember. The double, let's take a look up here. This double bracket x, that literally means go up, means the greatest integer less than or equal to x. Okay, so that's what that means. It means greatest integer less than or equal to x, whatever x is. Okay, that's what that literally means. So that's kind of how a step function shows up. All right, the second thing I want you to remember is this. All right, so if I've got 7.3, all right, the greatest integer less than or equal to x, that's going to be 7. All right, so I'm going less than. So if I've got something like negative 2.4, what's the greatest integer less than that? Well, that's going to actually be negative 3. Okay, I want to go 1 less than that. So that's kind of what that means. So again, this is kind of what the graph looks like. This is what the function looks like. So if I look at a constant function, that's this. Constant functions means y equals some number. All right, so y equals 7, y equals 3, y equals 2. Those are all constant functions. Constant in math basically means number. All right, identity function is this one up here. Identity is the perfect diagonal. Okay, and another way to put it is that x equals y, y equals x. It is the perfect diagonal going through the middle of the graph. All right, so f of x equals x, that is your identity function. So absolute value function goes like this. Absolute value function basically says I'm going to take a value, do some sort of absolute value part to it. I might do a couple other things to it, and then whatever my answer is, that's what I'm going to graph. So if I put negative 3 in here, absolute value of negative 3 is 3, 2, 1, 0, 1, 2, 3. Absolute value is actually a perfect V. Okay, no matter, usually wherever I put it, absolute value is going to be a perfect V, all right? It's different than a quadratic. Quadratic looks a little bit more like a combination of U and V. That's not what it is. This is going to be a perfect V. Piecewise function is exactly what it sounds like. For one part of the graph, you're doing one thing. For a second part of the graph, you're doing another thing, okay? So it's two or more inequalities. So, for example, taking a look here, negative x if x equals less than 0, x if x is greater than or equal to 0. So for all my values, negative x if x is less than 0. So that means take negative, negative 3, negative, negative 2, negative, negative 1. But once I get to 0, now it's just 0, 1, 2, 3. So 3, 2, 1. So it ends up being exactly like the absolute value function, just broken down into a piecewise form. So it says, for one range of numbers, do one rule. For a second range of numbers, do a number rule. So if I look here, this is going to be an absolute value one. There's a couple things that I want you to realize, okay? So two things are happening. I'm going plus 1, and I'm going plus 2. The plus 1 on the inside means that the entire graph is going to move left one space. Okay? The plus 2 on the outside means the entire graph moves up 2. So here's kind of how that works. You know, for any kind of function, and even if you think back to linear and quadratic stuff, you know, x plus, call it h, you know, plus k, where h and k are numbers. H is going to move it left and right, all right, and k is going to move it up or down, all right, and h is going to be the opposite of what you would think. K is going to be exactly what you would think. So here's kind of how that works. For h, opposite, so if I've got like an x minus, call it an x minus 3, I actually move right 3. Or like here, I've got an x minus 1, or x plus 1. That means I'm going to move left 1, okay? So my graph is just going to be like that absolute value before, except it's going to start 1 left and 2 up. So that's where my graph is going to start, and then it's going to look like a perfect V. Boom, boom. And I could put values in there. I could draw a little table, figure that out. But just realize this messes left and right. This goes up and down. So this is going to be a piecewise function. And what that means is that x less than 2, I do this. X greater than or equal to 2, I do this. So 2 is kind of my divisor right here. So right here is kind of where things go a little bit differently. So let's take a couple points here. So if I go, wait, sorry, back up. That's a negative 2. I want to go with positive 2. Sorry about that. So if I go negative 1, 0, 1, you know, I'm going to take x minus 4. So that's going to be negative 5, negative 4. And that's going to be negative 3. All I did was substitute it in there. But once I get to 2, my value is 1. Okay, my answer is 1. So at negative 1, I'm at negative 5. 0, I'm at negative 4. 1, I'm at negative 3. So this line's going to look like this. But then once I get to 2, my value becomes 1. So here's how that looks like. I come in here. Then once I hit that, I am at an open circle. Then, where x equals 2, I am a closed circle, and I go straight across. All right, so that is where it equals 1. This is a closed circle. This is a closed circle. because it's x less than 2. Okay, right on 2, that is where it changes gears. That's why this is a closed circle, because it's x greater than or equal to 2. So here, x less than 0, x plus 2, x greater than x if x is greater than or equal to 0. So 0 is kind of my splitter here. So if I go -3, -2, -1, I'm going to follow this rule. So I'll be -1, 0, 1. So at -3, I'm at -1. 2, I'm at 0. -1, I'm at +1. So now this is going to be my line kind of approaching 0. Then once I get to 0, it's exactly what its value is. So it's going to go here. All right. So then I'm going to go 1, 2, 3. It'll be 1, 2, 3. So I'll be the perfect identity function. So it's going to look like that. Again, open circle as it approaches 0. Then once it hits 0, close circle and keep going. All right, so let's kind of take a look here. No Leaks or Rust Plumbing Company charges $60 per hour or any fraction thereof for labor. Complete the table and graph the function where x is number of hours and c of x is my total labor cost. So anything up to 1 hour, so 15 minutes, 45 minutes, 1 hour, you're going 60. All right, so once I get 1 hour and 1 minute, they charge me another $60. 2 hours and 1 minute, they charge me another $60. 3 hours and another minute, they go up to, $240, $300. So it is very expensive to have a plumber at your house for longer than 4 hours. So at 0 up to 1, I'm at 60. So this is going to be an open circle at 60. Let me zoom in here a little bit. Open circle at 60, solid line, fills in. Once I get to 1 hour, that's my price. Then the second 1 hour passes, I'm into 2 hours. So I'm going to look like that. Solid circle, because I'm up until 2 hours, that's what I got. So once I get to 2 hours and 1 minute, I take over here. And once I take over into 4 hours, there I am up there. So that's going to be what my graph looks like. All right, so I'm taking it piece by piece, and each piece is a different value. So what this represents is like if I got a half hour, I'm still paying $60. If I've got 90 minutes, 1.5 hours, I'm paying $120. Okay, come talk to me with questions and start playing with these a little bit. If you want to look at them on a calculator, I can help you do that.